Let's get right into it. Every single piece of software, everything, is destined to change. It's just a fact of life in the digital world. But learning how to master that evolution, how to turn what feels like chaos into a real craft, well, that's one of the most important skills any developer can possibly have.
So here's our game plan. We're going to start with the big problem. Why does change so often feel like a step backward? Then we'll talk about the mindset you need to actually manage it. We'll even look at how some super high-stakes organizations get it right. We'll touch on the fundamental laws that govern all software, and then, the fun part, we'll get into the practical, hands-on techniques for writing code that's actually built to last.
Okay, so let's kick things off with a feeling I'm sure we've all had. You get that notification for a software update, you click install, and then suddenly things are just worse. How does that happen? Why is it so common?
To really get what's at stake here, let's zoom in on a massive, real-world example of software evolution that kind of stumbled right in front of everyone. And yeah, I'm talking about Windows.
Oof, that quote from an ex-Microsoft engineer, it really hits you, right? It just perfectly captures that frustration so many people felt with the Windows 10 updates. But it's not just complaining. It points to some really deep-seated issues. So what was actually going on behind the scenes?
Well, when you break it down, it comes down to a few key things. First, there was a culture issue. The source talks about this idea of made men. Basically, execs who had tried and failed in the mobile world were then put in charge of the desktop, and they just couldn't create a clear path forward. Second, a huge process change. Microsoft moved away from this giant army of people testing on real computers to automated tests on virtual machines. And it turns out, virtual machines just can't catch all the weird stuff that happens in the real world. And third, you just had this intense commercial pressure to keep pushing out updates constantly, which created this environment of nonstop risk.
All right, so if the problems are things like culture and process and pressure, where does the solution even begin? Well, it's not with some fancy new tool. It actually starts with a huge shift in how developers think about their job. It all starts with something called the programmer's mindset.
So what is this exactly? At its core, it's about a total change in perspective. It means you accept that your job isn't just to build a cool new thing and then walk away. No, your job is to be the guardian of that software for its entire life. All of a sudden, change isn't some annoying chore. It becomes the whole point.
And I love this comparison because it's so perfect. On one side, you have the architect. They design the shiny new building, but they're long gone when the roof starts leaking 10 years later. To them, maintenance is just boring. But then you have the evolutionary craftsman. They're there from day one, and they're still there for version 10. They understand that evolving the software is the craft.
Okay, a great mindset is one thing, but how do you actually turn that into a process that works every time? To figure that out, we can look at organizations where software failure is like not an option. We're talking life or death consequences. Let's see how they handle it.
Take the FDA, for example. They approve the software that runs on medical devices. They don't just see change as one big messy category. No way. They break it down with surgical precision. Are we changing the compiler? That's an infrastructure change. Are we tweaking the algorithm for a heart monitor alarm? That's a core algorithm change. Or are we just, changing a logo? That's cosmetic. Each one of these has a completely different level of risk and gets a completely different level of attention. And you see the exact same kind of serious thinking over at Harvard. Look at the words here. Standardize, review, assess, document. It's all about discipline. Every single change has to be formally requested, its impact is carefully evaluated, and everything is logged. They have totally separate environments, so untested code never, ever gets near the live system. They even have a plan for when things go wrong. See? This isn't chaos, this is control.
So on top of these discipline processes, it turns out there are these fundamental principles. They're almost like the laws of physics, but for software, that explain how all complex systems behave over time. And if you want to manage change, you've got to understand them. Way back in the 70s, a guy named Manny Lehman came up with these laws, and they're still so true. The first one is basically, if your software isn't changing, it's dying. The world moves on, and your code has to keep up. The second law says that as you add more stuff, the whole thing naturally gets more complicated unless you're actively working to simplify it. And because of that growing complexity, the third law says the quality will always feel like it's going downhill unless you are constantly fighting against that decay. It's like entropy for code.
Okay, so we've got the mindset, we've got the structured processes, and we understand the laws of nature for software. So now, how does all of this actually look in the code itself? Let's roll up our sleeves and get practical. And here's the cool thing. These principles are pretty much universal. Doesn't matter if you're writing JavaScript or C++. First, clarity is king. Name your stuff so it reads like a sentence, not like a secret code. Second, one function should do one thing. That way, if you need to change it, you don't accidentally break 5 other things. Third, no magic numbers. Don't just have a random 5 sitting there. Give it a name so we know what it means. And finally, separating your concerns and using encapsulation, that's all about building good fences in your code so one part can't mess with another. It's not just about making code that works now, it's about making code that's safe to change later.
And this slide shows you everything. On the left, you have pure chaos. What is class 1? What does it mean if type is 1? It's a total mystery. It's a trap just waiting to spring on the next developer. But then look at the right. That is craftsmanship. The class is a discount manager. The method is apply discount. Instead of magic numbers, you have a clear account status. And all that complex logic is broken out into these neat separate classes, using patterns that are literally designed to make it easy to add new discount rules later, without breaking everything. It's not just a little better, it's a completely different way of thinking.
And that brings us to our final and maybe most important point. Managing change, at the end of the day, isn't really a science. It's not a formula. It's about your approach, your philosophy. It's about the legacy you're leaving behind in the code.
Because that's the thing to remember. At its heart, programming is a creative process. There isn't always a single objectively right answer. Just like any art form, it's about elegance and clarity and even a sense of taste. It's a deeply human activity.
And this is what ties it all together. When you truly adopt that programmer's mindset, you stop seeing your code as some static thing you build. You see it as a living, breathing entity. Change isn't a problem to be fixed. It's just a natural, essential part of its life. And guiding that evolution, well, that is the art.
So that's the question I want to leave you with. When you look at the code you write every day, what do you see? Is it something that can grow and adapt and evolve with grace? Or have you built a trap for the next person who has to touch it? Who, by the way, might just be you 6 months from now?